This video will apply Rubinstein bargaining analysis to determine what the size of the UK's divorce bill from the European Union will be. This video does not find the agreement reached in practice, nor the fairest agreement, but rather determines, assuming rationality, what will be the size of the divorce bill. The divorce bill is the amount of money Britain will pay to the EU to settle the UK's outstanding liabilities and commitments. Its exact figure will be confirmed in the withdrawal treaty. Theresa May began the Brexit process by triggering Article 50 on the 29th of March 2017, so this is assumed to be the start point of the divorce bill negotiations. How much the UK owes is subject to great controversy, so for the sake of this model, we have used various newspaper reports from 2017 to estimate the maximum and minimum bounds to which the UK could be liable. Rubinstein bargaining is a strategic, non-cooperative, infinite horizon game, meaning theoretically the rounds of the game can go on forever. Player rationality and complete information are assumed. It is set up as follows. There are two players who must divide a pie of size 1 between them. They take turns to propose an offer of some portion of the pie to the other player. This player can accept or reject their offer. If they accept, the game ends and the players receive their payoffs. If they reject, the game continues to the next round. The game incorporates a discount factor that represents the cost each player incurs as a result of the time delay. The greater the patience of the player, the closer their discount factor will be to 1. Therefore, if one player is relatively more patient, they gain bargaining power since they are willing to reject offers and wait for a better deal. Player 1 is Theresa May and Player 2 is Jean-Claude Juncker. The original and largest figure the EU proposed was around €100 billion, and the minimum reported was a no-deal scenario where Britain refuses to pay. To apply our analysis, we assume that pi is equal to the maximum payout that the UK may be liable for in a worst-case scenario, allowing us to calculate the division of the divorce bill pi between the UK and the EU. We also assume that the UK proposed the first offer since they chose to leave the EU. This gives the UK first mover advantage. This is where the discount factor erodes away the value of any future agreement, so the player going first can take advantage of this and demand slightly more. This is reflected in the difference in final payoff equations for each player. The model we present does not require players to have equal discount factors. In this case, we'd expect the UK to be slightly less patient since the effect of a long negotiation process will have greater impact on a smaller economy. We hence assume that May's discount factor is 0.9, whilst Yonkers is 0.95. Assumption 1 holds since the divorce bill is a key part of the Brexit deal and could be worth up to €100 billion. Assumption 2 holds because the UK and EU are closely linked trade partners who are striving hard to avoid a no-deal Brexit. Assumption 3 is valid because the longer Brexit negotiations drag out, the greater the length of uncertainty for European businesses. Assumption 4 holds since it is natural to assume that players have continuous utility functions, which increase as they receive a greater portion of the pot and decrease as the period of receipt extends. Assumption 5 refers to the use of stationary strategies by the players, which means that the negotiators on either side of the deal will not change strategy between periods if those periods are identical. The game is solved using backwards induction. We start in any odd period n, where May makes an offer to Jonker. Jonker can then look forward from this point and determine his continuation value, denoted Vj, which is the non-discounted amount he expects to receive if he rejects in the current period. This is then multiplied by the discount factor delta j, because if he receives Vj in the next period instead of this one, it is worth less due to the time delay. May then knows she must offer at least delta j Vj for him to accept, so this is what she offers. This means her payoff will be 1 minus delta j Vj. Moving now to the even period n-1, Jonker will know that May's continuation value is equal to the bottom left quadrant, and therefore will offer her this amount multiplied by her discount factor, delta m. Jonker will therefore receive 1 minus May's payoff, as shown in the top right quadrant. This method works because both players have a discount factor that is less than 1, so when one player proposes an offer, it is in their interest for the other player to accept, and so they immediately offer the amount they know will be accepted. Therefore, the game ends in the first round, despite the fact that it can continue forever. From this, we can see that in period n-2, Jonker can expect to receive the value in the top right quadrant if he rejects May's offer. Therefore, this is his continuation value. To solve for Vj, we expand out the brackets on the right-hand side. We then move all the Vj's to the left-hand side of the equation, factorise them out, and rearrange to solve for Vj. Now that we know Vj in terms of the discount factors, we can substitute them back into payoffs. Since we assume May proposes the offer in the first period, we substitute the formula for Vj into the bottom right quadrant to determine her offer, denoted xj, which Jonker accepts. To solve, we substitute in the maximum divorce bill size and the discount factors for each player, giving a divorce bill payment of €65.5 billion. The key lessons from this solution are that to best one's outcome in any bargaining situation that fits the Rubinstein structure, one should focus on increasing their position by A. Obtaining first mover advantage, and B. Situating themselves such that their discount factor is close to 1.